On this 2.7-liter EcoBoost, 238 kilowatts to 324 PS, Ford F150, P0053 may point to a problem in the universal oxygen sensor heater circuit. The truck may only show a check engine light, and it can still seem to run normally, but heater circuit faults can affect how quickly the sensor comes online and how confidently the PCM can manage fuel control. The possible fault areas often include the sensor heater, the power feed, the heater control circuit, related signal and reference circuits, connector condition, harness damage, or only after the circuit checks, a possible module side issue. Start with the basic system checks. If other codes are present, check what they mean first. But for this job, stay focused on the suspect universal HO2S indicated by P0053. If the engine or exhaust is hot, take the normal precautions around hot components. Some heater checks may be made after the heater has been on for 2 minutes, so treat the exhaust area like it can be hot. Before moving into the P0053 universal sensor path, keep the downstream heat and oxygen sensor heater path separate. If the scan result points you to that downstream HO2S heater circuit instead, start by checking the listed heater DTC routing. Then, with the ignition off, verify the HO2S connectors are on the correct engine bank. Inspect the harness, the HO2S connectors, the PCM connectors, and any inline connectors for crossed wires, loose or incorrect connections, damaged or spread pins, pinched or shorted wiring, corrosion, oil or water contamination, and sensor damage. If you find a concern, repair it as needed, clear the PCM DTCs, and repeat the self-test. On that separate downstream heater path, diagnose only the suspect sensor indicated by the scan result. With the PCM connector connected, disconnect HO2S12 and HO2S22, turn the ignition on, and check VPWR at C142 pin 2 for HO2S12 or C141 pin 2 for HO2S22. The voltage should be greater than 10.5 volts. If it is not, repair the open circuit, clear PCM DTCs, and repeat the self-test. If VPWR is good, turn the ignition off, disconnect the PCM connector, and check the heater circuit for an open. C142 pin 1 to C1232T pin 77 for HO2S12, or C141 pin 1 to C1232T pin 81 for HO2S22. That resistance should be less than 5 ohms. Then check the heater circuit for shorts from pin 1 to the listed pins and reference points. The resistances should be greater than 10,000 ohms. After that, check heater internal resistance on the component side, pin 1 to pin 2. It should be between 2 and 30 ohms. If the downstream heater internal resistance is in range, check for an internal short to ground on the component side, from pin 1 to pin 3 and the listed reference. The resistance should be greater than 10k ohms. If it is not, install a new heated oxygen sensor, reset KAM, and repeat the self-test. If that check passes, the next downstream path checks PCM internal resistance with all PCM connectors disconnected. The listed measurement groups do not clearly call out that downstream heater code path, so if the exact return point is unclear, pause, recheck the earlier diagnostic path, and avoid guessing. If the path does lead you to the final downstream operation check, inspect for pushed-out pins and corrosion at the PCM and HO2S12 and HO2S22 connectors. Reconnect everything fully seated, reset KAM, and verify whether the concern is still present. If it is still present at the HO2S check, install a new HO2S in question, reset KAM, and repeat the self-test. If the path proves a PCM side concern, and the concern is still present after connector inspection and reseating, install a new powertrain control module and complete the required programming setup for that replacement. Now, for the P0053 universal HO2S path, start with the ignition off and inspect the universal HO2S harness and connectors before grabbing the meter. Look for pinched or shorted wiring, loose or spread terminals, corrosion, oil or water contamination, crossed sensor wires, and a damaged sensor. If you find a concern here, repair it as needed, clear the PCM DTCs, and repeat the self-test. If the visual inspection is clean for P0053, move into the heater circuit checks. If the diagnostic route sends you through the extra screening step before the heater checks, do not skip it. Check for a misfire concern and look for non-factory or aftermarket equipment that may increase exhaust temperature. With the ignition off, disconnect the suspect universal HO2S connector and check that connector for damage or corrosion. If there is a concern, repair it as needed, clear PCM DTCs, and repeat the self-test. If not, continue into the same heater circuit testing path. Next, check the UO2 SHTR circuit for a short to voltage. Keep the ignition off, disconnect the PCM connector, then turn the ignition on. For the suspect universal HO2S11, check C171 pin 5. For the suspect universal HO2S21, check C172 pin 5. Any voltage present means repair the short circuit, clear the PCM DTCs, and repeat the self-test. If there is no voltage, continue. Now check the UO2S, UO2S GREF, and UO2S HTR circuits for opens. On HO2S11, measure C171 pin 1 to C1232T pin 44, C171 pin 2 to C1232T pin 45, and C171 pin 5 to C1232T pin 47. On HO2S21, measure C172 pin 1 to C1232T pin 43, C172 pin 2 to C1232T pin 42, and C172 pin 5 to C1232T pin 46. You want less than 5 ohms. If not, repair the open circuit, reset KAM, and repeat the self-test. If those circuits pass, reconnect the PCM connector, leave the universal HO2S disconnected, turn the ignition on, and check VPWR at pin 4 of the suspect sensor connector. The voltage should be greater than 10.5 volts. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. If VPWR is good, turn the ignition off, disconnect the universal HO2S and PCM connector, and check the heater circuit open again. C171 pin 5 to C1232T pin 47 for HO2S11, or C172 pin 5 to C1232T pin 46 for HO2S21. That resistance should be less than 5 ohms. If it is not, repair the open circuit, reset KAM, and repeat the self-test. After the open and power checks pass, check the UO2S HTR circuit for shorts. With the PCM connector disconnected, measure only the circuits that apply. On HO2S11, check from C171 pin 5 to the other listed C171 pins and the listed reference. On HO2S21, check from C172 pin 5 to the other listed C172 pins and the listed reference. The resistances should be greater than 1000 ohms. If not, repair the short circuit, reset CAM, and repeat the self-test. If the harness side passes, check the internal heater resistance of the universal HO2S on the component side. Measure between pin 4 and pin 5 at the suspect sensor connector. The heater should read between 1.8 to 6 ohms, cold, or 2 to 14 ohms, normal operating temperature. If it does not, install a new universal HO2S, reset CAM, and repeat the self-test. If heater resistance is in range, check the UO2S HTR circuit for an internal short to ground to pin 5 on the component side. That resistance should be greater than 1000 ohms. If it is not, install a new universal HO2S, reset CAM, and repeat the self-test. For the bank 2 check, if the connector callout is not clear, pause and confirm the exact connector before measuring. If the heater and internal short checks pass, keep working through the related universal sensor circuits. With the ignition off and the universal HO2S and PCM connectors disconnected, check the UO2S and UO2S GREF circuits for opens. On HO2S11, measure C171 pin 1 to C1232T pin 44, and C171 pin 2 to C1232T pin 45. On HO2S21, measure C172 pin 1 to C1232T pin 43, and C172 pin 2 to C1232T pin 42. The resistance should be less than 5 ohms. If not, repair the open circuit, reset KAM, and repeat the self-test. Then check the UO2S, UO2S GREF, UO2S PC, and UO2S PCT circuits for short to ground, measuring only the circuits that apply. At the sensor connector, check pins 1, 2, and 3. Those resistances should be greater than 10,000 ohms. If not, repair the short circuit, reset KAM, and repeat the self-test. Next, check for shorts between those circuits. On either bank, compare pin 2 to pin 1, pin 2 to pin 3, and pin 1 to pin 3. Again, the resistances should be greater than 10,000 ohms. If not, repair the short circuit, reset KAM, and repeat the self-test. Finally, in this group, turn the ignition on and check pins 1, 2, and 3 for a short to voltage. Any voltage present means repair the short circuit, reset KAM, and repeat the self-test. Next is the current trim resistor check inside the universal HO2S. For vehicles without a UO2S PCT circuit, treat this branch as the passing side. With the ignition off and the universal HO2S disconnected, check the applicable resistance for the suspect sensor. It should be between 25 to 330 ohms. If it is not, install a new universal HO2S, reset CAM, and repeat the self-test. If it passes, check the UO2S-PC and UO2S-PCT circuits for an open, measuring only the circuits that apply. Only the 6-pin universal HO2S has a UO2S-PCT circuit. On HO2S11, measure C171 pin 3 to C1232T pin 59. On HO2S21, measure C172 pin 3 to C1232T pin 57. The resistance should be less than 5 ohms. If not, repair the open circuit, reset CAM, and repeat the self-test. Then check the UO2S PCT circuit for short to ground. If the vehicle does not use that circuit, follow the passing side of the branch. Where the circuit applies, resistance should be greater than 10,000 ohms. If not, repair the short circuit, reset CAM, and repeat the self-test. Last, check the UO2S PCT circuit for short to voltage. If the vehicle does not use that circuit, follow the no voltage side of the branch. Any voltage present means repair the short circuit, reset CAM, and repeat the self-test. With no voltage present on this P0053 path, go to the final operation check. If you are doing an exhaust pressure leak check around oxygen sensor work, protect the exhaust components. Pressure above 241 kilopascals, 35 psi can cause damage to system components. So use 34.4 kilopascals, 5 psi regulated shop air before connecting to the system. When checking near the downstream sensor area, pay close attention within 15.25 centimeters, 6 inches, of the downstream HO2SS. Keep verification separate from the testing. With the ignition off, disconnect all PCM connectors and disconnect the HO2S11 and HO2S21 connectors. Inspect for pushed-out pins and corrosion. Reconnect the PCM connectors and both universal HO2S connectors, and make sure every connector is fully seated. Reset KAM, then verify whether the concern is still present. If it is still present, install a new universal HO2S, reset KAM, and repeat the self-test. If the concern is gone, the system is operating correctly at this time, and the issue may have been caused by a loose or corroded connector. A separate secondary HO2S fuel trim check may call for starting the engine, monitoring LGS02FT1 and LGS02FT2, and looking for an indicated value between negative 1.6% to plus 1.6%. Takeaway: P0053 is an electrical diagnosis, so prove power, opens, shorts, heater resistance, and connector integrity before making the final call. For more diagnostic training, visit stepdiagnostics.com.